we could probably start.
Yeah, I agree. Okay, so hey everybody, thanks for joining. So this is our general stateless community call. We've had a couple of topical ones since the last general one. Um, so we've sent out in the mailer uh, uh, the agenda that we're going to be covering. So let me just state that here. So we're going to be going over any updates, if available, on the vertical tree migration. Um, and then we're going to talk about specifically one of the topics that Vitalik has been writing about, which is the uh, epoch-based state expiry. And ideally, there's been some discussion about it versus regenesis. So maybe we'll have a little bit of ongoing discussion from people about that. And then third, Piper has put together a kind of document talking more generally about the stateless roadmap. And I think it would be helpful that we could have people who, especially taking a look at that, just get an update about that or also give some input. So I think let's start off with the first item then. So on the vertical tree migration, um, we could talk about any updates on that. I see Vitalik, you are on. I don't know if you wanted to say a few things about it.
Hmm. Is Guillaume on the call by chance?
Yep.
Yes.
Yay. Okay. Well, you're the better person than me to talk about vertical tree updates.
Yeah. Right. So basically, we started writing a library that is called. I don't know if I can share my screen to so that you guys can see the address. Otherwise, I'll just give you the link. No.
You should be able to share the screen. I don't think I have to give.
Right. I don't know if you guys can still hear me, but my computer completely froze.
Yeah, we can hear you perfectly. So
Okay.
so you're optimizing the audio channel. That's why everything else froze.
Yeah. Okay. Well, I'm gonna try to do it without sharing my screen then. But the idea is we created a repo that's called Go Vertical. So it's in my private repo. I'll share it after our reboot because apparently I have to. And the idea is this is like a generic vertical tree that anybody writing Go could use. It's been validated against the Encrad prototype, and now we started implementing it, starting using it in Geth to start offering some insights into how much time it takes. And so we started running it into mainnet. So normally I have some nice numbers to show, which are available in the README. I'm not able to show you at this time. But that's quite interesting. So I would say the interesting point, the most interesting number is that we managed to verify a proof in roughly 4 milliseconds. And so what we do is also we calculate.
So how many keys?
Just one actually, but verification should not actually should matter a bit. So it's not very impressive, but it's still nice to know that it's still a sensible time.
And that's using KillHBLS, I assume, not Blast.
That's actually with Herumi.
Herumi. Okay.
And what else? The other interesting number was that it would take, like the internal try itself would take 55 gigabytes. That's with so each node can have a variable size, but we did all our tests with 124 children per node. and yeah, it takes 55 gigabytes, so that's smaller than the MPT. But we're still looking, like the encoding was not was kind of naive, so we'll see if we can come up with something smaller even. And yeah, we can calculate a like take the mainnet at a block that was around the beginning of the year, and we can compute the root Merkle, sorry, the root commitment for the entire tree and save all the internal nodes to the database in roughly 14-15 hours. So that's, yeah, that's as a first approach, that's pretty encouraging. And when it comes to what we want to do next, so there's a post by Vitalik on the magicians that explains how to merge the account trie and the storage tries. So we're going to do this. And otherwise, yes, what we want to do, like I think the step at this stage, the next step is to be able to modify Geth to produce proofs at every block, and see if we can build a test net from that, or at least join a test net and keep publishing proofs. Yeah, that's pretty much it for the current status, I mean.
Excellent work, Guillaume.
Thanks.
Yeah, that's great to hear. That's a lot of progress. One question
I
remember when Dan Crowd was kind of presenting it, it looked like there were options in the Verkle tree for how much you attempt to save in the witnesses that are being, oh, I guess.
The width is a parameter.
Yeah.
Yeah.
So
Guillaume, you have left that as a parameter, right? So you could easily adjust it.
Yes, I'm about to push a PR where you can pick whatever widths you want. Well, okay, maybe not whatever, but at least between.
Oh, looks like his computer finally froze. That's cool. All right. Well, he may come back in a little bit. We'll see. But otherwise,
is anybody other than Guillaume able to give some context to that 15-hour number? Whether it's like, is that sort of just how long it would take a client to, like, we now like have like an upper bound on building out the tree, like migrating from the current tree? Is that the context there?
So, yeah, the context is this particular benchmark reads the whole state from a snapshot in Geth and builds a Verkle trie out of it. And it tries to do this concurrently to utilize, like, if you have multiple CPU cores. And yeah.
Cool. So we don't have like a firm migration plan, but to like contextualize that number, if we were to do a stop and halt the world and then start the world back up, then now we have this sort of like 15-hour upper bounds that we can work on that might be roughly what the stop and halt the world is. I'm not proposing we do the stop and halt the world, but
I think that's only the account trie as far as I understand, right? That wouldn't include everything else you want to store in there. So it might not be the upper bound.
I thought
it does include the storage. Yeah, it does.
Oh, it's everything. Okay, good.
Yeah.
All right. Yeah. Okay, then it's an upper bound.
I'll extend off of that. I linked in the Zoom chat the post from Vitalik on unifying the Verkle tree. That's probably just worth people looking at. It's just an updated scheme for how we're looking at laying out all of the data in the tree. And if anybody has questions, happy to go over those as well. Sina, a question from the chat. What kind of machine was the 15 hours benchmark made from?
I can look into that. That's Amazon VM. Let me look it up a second.
Cool, thanks.
Also, just another question on the that stat in the meantime. But what algorithm was used to build the tree? Was it just a naive insert things one by one, or was it some algorithm that created the tree together at the same time?
I think this is Guillaume would be the better person to answer this question, but as far as I know, it was insert the leaves one by one.
Okay, so that gives us for just constructing the tree, that gives us an easy, maybe like factor of 3 or 4, something like that improvement.
Looks like Guillaume is back. He may be mute. No. Well,
Yeah, I noticed a difference between the Go and the Python one is that the Python implementation updates the commitment as they kind of insert with this value change variable, while in the Go implementation, it looks like the commitment is computed at the end. So I think maybe the Go one can be made faster if you compute this delta value while you're inserting.
If you build up the whole tree, it's faster to first create the full tree and then compute all the commitments, because then you can do multi-exponentiation.
Right.
So that's and actually the Python does both. If you look at it, I've implemented both variants. So you can build up a tree first and then compute commitments, or alternatively, you can update a tree while you're inserting. Both are possible.
Right. So insertion, like when you're inserting in the tree, you want to insert without computing the commitments and then do the commitment at the end. But when you're updating, you want to compute the delta, right? Yeah.
Yes, exactly. Yeah.
I'm also aware of somebody who's been working on a Rust implementation of this. I do not know who it is, but I know that they're out there.
Yeah, sorry, that was me. I'm still kind of
Excellent.
working on the numbers. It's not as great as the Go numbers for inserting 10K. Inserting 10K leaves into the try. I think it's about 40 milliseconds now. I'm just working on improving it just to see why it's so bad. Yeah.
If you'll reach out privately, there's a like small Telegram channel that's got a little bit of Verkle specific discussion going on that it seems like you should jump into.
Right. All right. Thank you.
So zooming out to sort of like roadmap level stuff, this kind of fits the model of how this kind of thing seems like it needs to get developed, which is Guillaume's doing awesome work to figure out some of the just down in the trenches stuff. Guillaume, are you back on the call? I thought I noticed you jump in, but
Yes.
cool. Do you have can you give us like a sense for timeline? It just guesswork, basically projection of like timeline going forward to where it might be time for other people to step into this, or kind of how can we support you and kind of what comes next with this?
Right. So timeline, it's always difficult to say, but I think we're shooting at something after the merge. I mean, if the merge continues on, on its current pace. Supporting, well, I like small teams, like focus teams. There are a couple things that could be where there would be value. One of them was the post by Vitalik, the more about change, like the format of the tree, like when you merge the the storage try and the account try. So a lot of feedback on that would be great, because we're going to start implementing that soon. So the more certain we are about this, the better, so that we don't have to reinvent the wheel every time. And otherwise, when will there be a need for people to implement? I think right now we're still, I would say for the next couple, maybe a month, we're still, I think, in a research mode. So I don't think there's a need to look where a lot of problems are. But yeah, I would say by at the latest by the end of the quarter, it would be interesting to have other people have a look into that. Another thing would be to try. I mean, I can't pronounce your name. I'm sorry, but Kev Andre. If you're since you're programming this thing, this Rust library, trying to put it into Open Ethereum, if you have the time to do that, would be also, I think, fairly interesting.
Yeah, sure. Should it use RLP encoding?
No, RLP. I mean, the RLP encoding we use is just for the database. I would say let's not put the database in the spec. It's really whatever works.
Right.
It seems like maybe a good that going over that just very briefly, running through that the updated tree layout might be worthwhile, just to kind of put it in front of people and see if there's any obvious things that jump out.
Yes, that would be nice.
Cool. I can do that. Let's see if I'm able to actually share a screen. It looks like I can. Cool. This is the post from Vitalik on the ETH Magicians forum. I'm gonna run through this pretty quickly, but the general gist was trying to co-locate things in the tree that are beneficial to be co-located, such as contract storage and the Merkleized code. Trying to get all of these things into the same tree, so no multi-trees. So this is all just one unified tree. So that means that the Merkleized code is part of the tree, the storage is part of the tree, the account fields, which I think we're referring to as the account header, are part of the tree. And the general gist, let's see, do we have a good overview? Nope, here we go. Is that, well, it's this post here. We've got sort of a common prefix for where all of the header stuff lands. And then we've got another common prefix for where the code, like the Merkleized code lands, and for where the storage lands. But one of the important properties, or at least that I pushed for, and that I think is good that we're maintaining here, is that the tree is uniformly balanced across, with like some asterisks there for the just random variance, but essentially the entire tree is relatively uniformly balanced across a 32-byte key space. And that becomes important for doing things like sharding the state data in some sort of secondary network. It's one of the problems we've run into with the current tree with the kind of like heavy contract subtrees living under it. So, and the other thing this gives us is relatively easy extensibility for the account. So adding extra fields to the account is relatively straightforward in this scheme, just because we stick a new there's essentially namespaced in there. So anybody, people should take a look at this. It's a change from the layout. If there's any other kind of like deficiencies of our current layout that this isn't addressing, this is the time for us to address those. So yeah, anybody with questions or thoughts, speak up.
Yeah, I thought I would just add a listing of like what I see the important properties of this are. So one is that it's a single tree. So there is a kind of tree inside of a header inside of a tree mechanic that exists in the current Hexary tree, which is just allows for a massive simplification. Number two is that related data can be stored beside each other, and that kind of cuts witness sizes down. So it basically allows like very, very efficient and compact witnesses going to the code. And it also allows very efficient and compact witnesses to adjacent pieces of storage, which is something that we do not have today, but would be really cool to have. A third thing is that it makes it extremely easy to add more account header fields in the future, as opposed to today where like, we would basically have to go in and change the entire RLP. And then obviously the fourth is the uniform distribution aspect.
Yeah, to highlight that one piece, I think what we ended up with was a scheme where the code generally is all like chunked up together nicely. And now we actually get sections of each section of 1024 contract slots are also co-located in the tree.
Right.
Is that correct?
It's 256 instead of 1024 in at least my model, but that's obviously a parameter that can be changed. But yes, so like if you have two storage keys and those storage keys are in the same kind of 256 size chunk, so the first 31 bytes of them are the same, then like they're actually going to be beside each other in the witness. And there's lots of contracts that can benefit from that because they just have like a lot of environment variables in slots 0 to 255. And so the practical witness sizes for those will just go way down.
Yep. Yeah, that's a nice thing for, well, just for that kind of contract.
Piper, I had one other question, which is there any other place where there's spatial locality that is beneficial in some way in the, existing state storage or storage trees that goes away with the merge that you see or you think you might be concerned about?
No, not that I'm aware of, and this proposed scheme addresses a major problem that just shouldn't be there after we migrate to this. That problem, by the way, is that there is no way to evenly distribute the Ethereum state naively. So you cannot, without knowing what the state looks like right now, it's not really possible to evenly distribute it up so that it's easy to find all of the pieces because you have these very heavy contract subtrees, and this gets rid of that.
Very cool. Thank you for that. Okay, the second item we had on the agenda was this topic about epoch and regenesis. And a couple of us put this on here because we've been talking about regenesis and the epoch schemes that Vitalik, you've written a bunch of good posts in the last month or two about. And we just wanted to have a quick discussion about it. This may only be a couple of minutes, but we still thought it was kind of worthwhile. Just the discussion, I think the discussion included myself, Joseph Chow, Piper, and Alexi at various times. And it's a little bit of a question or two about what you've been proposing kind of versus regenesis. And maybe I could start it off, Vitalik, by just kind of directly asking, you proposed the epoch-based state expiry scheme, and it's a little bit maybe not entirely clear because in writing about it, you've written about it, the epoch scheme is kind of standalone, and regenesis, which we were thinking about before you kind of discussed how epochs can take care of the fact of dead addresses and other things, was sort of the prevalent scheme we were looking at with Epoch, the Regenesis as an individual version is gone. I was interested if what was your sort of take about, doing the Regenesis schemes versus what you proposed in Epoch? How did you think about the two?
Sure. So I think, like, first of all, my understanding of Regenesis is that Regenesis is also an epoch-based expiry scheme, right?
Mhm.
Like, you have epochs, and then at the end of each epoch, the state that's in that epoch kind of expires from being the active state. And then you can put objects back in if either they're completely new objects or they're objects that got resurrected that were active in the previous epoch. So I feel like that general kind of roadmap for how to do state expiry is something that all of the proposals agree on.
Mhm.
The key additions in at least my own proposal, one is the concept of address spaces and the idea that you can create a new account in a new address space. And to do this, or if you do this, you don't need to provide a witness because there's no possibility of creating that same object in an earlier epoch, and so there's no risk of resurrection conflicts. So that whole thing was basically just a strategy of dealing with resurrection conflicts. And then the other thing that I feel is key in this proposal is that it doesn't require any notions of like partial tree storage. So there's no concept of, oh, in the tree, we're going to add intermediate nodes, and those intermediate nodes are going to carry data, and that data is going to be like metadata about that subtree. And instead, like this approach that I proposed basically preserves the abstraction that the state trees are just clean key value tree dictionaries that have no other properties, which I thought is just a nice abstraction to have because it makes it easier to build and potentially upgrade state storage formats in the future.
Yeah. Okay. Okay. So one
So
question.
to
Yeah.
cover the thing that you mentioned, which is sort of like, how does this differ from Regenesis? The terminology that I've been playing around with, and we can all agree or disagree or whatever, is that previously we've used the term Regenesis to capture the concept of state expiry and the concept of establishing a new Genesis block. And I think it's maybe worth us tugging those apart and treating them as separate concepts, because we can do state expiry without doing a new Genesis block. And vice versa, we could do state expiry and then we could do Regenesis later and just start doing that, resetting to a new Genesis block independent of state expiry. So.
Yeah, that's a well put way. I think one of the things, Vitalik, that so it's good to hear that you also view it as Regenesis is in there in the Epoch scheme. It is in there. The one thing that you modified though versus the original Regenesis is that Regenesis now in the Epoch scheme is something that lives with a sort of a current Regenesis period and a previous Regenesis period, which both are active. And the Regenesis that's forgotten is actually 2 blocks or 2 periods back.
Right.
And one of the and so I think there was a big resistance. Alexei had gotten very strongly on the idea with Regenesis that the cleanest and simplest Regenesis was this idea that there was only the current Regenesis. And so at the end of the current Regenesis, all nodes forgot everything. And so there was an inherent property of the way Regenesis was being spoken about that everybody got used to understanding as a problem as a result, which was that there's going to be big state witnesses every time the Regenesis period ended. So, what you've kind of elegantly put in here is you've put in two periods being active. And that means, let's say if the Regenesis period was 6, or let's say if the Epoch period was 6 months, that would mean that at the end of, at a 1-year boundary, or every second 6-month period, when you have the end of the current regenesis period, you would not forget the last 6-month state. You would forget month 7 through 12 is what would be taken out. And, that is a huge benefit, because it means that there will still be an increase in witness sizes, because the amount of state that's being held by the clients will drop from 12 months to 6 months across a single block boundary on the chain. And so certainly witness sizes will increase, because there's a lot less state, to pull from in 6 months versus 12 months. But it's going to be nothing like when, you go from 6 months to 0 in the original regenesis scheme. So, I think a little bit of I guess Piper said it, one way, which is saying, if we separate this idea of expiry and regenesis, we could do state expiry with the epochs and then do regenesis later. I guess as just a discussion, if people had thoughts, it looked to me also like there's, the other view, which is if we're looking to do light clients, or to do lighter clients that don't have to hold as much state, the state expiry, I viewed it this way, and please correct me if I'm wrong, that the main purpose of the epochs and the state expiry is in order to open up clean address spaces, so that people don't have to hold around state in order to know, where they can insert new addresses without having conflicts with things that have been forgotten already that they're not aware of. And, until we get to a point where the address space has had so many Swiss cheese holes inserted in it, that's not a huge problem. And so out of the two, the regenesis seemed more important for ETH2 to actually get in, because it means that people that are, participating will be able to participate holding a relatively small cache of state, and then receiving relatively small witnesses. And so that one seemed more important. So I actually saying sort of similar thing to what Piper is saying, but in my mind, it was almost a reverse of, doing the current plus previous regenesis, that modification to get rid of the big witness size bursts for regenesis seemed like it would be more valuable for, a post merge, and the state expiry could be done later.
Right. I'm not infinitely attached to the whole kind of keep the current and the previous thing. My reasoning for that, one is, as you've said, it basically stabilizes the state size, and so it only jumps up and down by a factor of 2 instead of jumping all the way down to 0. The other reason is that it preserves the property that if you have an account, then as long as you touch that account at least once in epoch, you never have to provide witnesses or interact with any protocol that gives you witnesses, which seems like a desirable property. Basically, the only time you have to interact with witness gathering infrastructure is if you kind of forget to keep your state updated. So that was one thing. And then in terms of which is valuable, it's not so much an either or, right? The state expiry, well, when we do state expiry, either it would be 2 epochs, either we'd be storing 2 epochs, or we'd be storing 1 epoch. If we really want, we could store 1 epoch at the beginning and then move over to 2 epochs in the future. And so that way, clients would just be able to kind of forget the Patricia tree state, which could be a good simplification. There's also the discussion about whether we care more about state expiry or history expiry, right? If we do history expiry, then the users and clients and proposers and everyone would still have to download the full kind of big state or whatever the state is, but just from the sync process point of view, there would be no, the protocol would not care about the blocks and the transaction history and receipts that go beyond a certain point. And that's something that does seem valuable too. If post merge, we can move pretty quickly toward forgetting everything that happened before the merge, then I imagine that would allow a huge amount of code simplification, because the only history you'd need to download effectively would just be the beacon chain. But like those feel like separate projects, and I could see separate teams working on them.
And speaking of teams working on this, this is something that we could absolutely use a team working on. So if there is a client team out there who wants to do similar to what Guillaume is doing with figuring out the Verkle tree stuff, that's something that I think that we could find support for. Somebody's going to just have to get their hands dirty in a client and start implementing this, because it's worth pointing out that hiding inside of this are 2 or 3 other relatively non-trivial changes. One of them is increasing the address size up to 32 bytes. The other is, did we have to get rid of self-destruct? Is that part of this?
We have to get rid of self-destruct for statelessness.
Right, so we, well, and for, yes. So there's a couple of things kind of like hiding under the hood here that need to happen, and we need a team to come along and pick those things up and figure them out. And yeah.
Well, I guess realistically, we might even need like 2 teams, right? Like one is, well, there's obviously this existing stateless team. We would want a state expiry team, and I think we want some kind of more organized history expiry effort as well.
So I like this term history expiry. Is history expiry now the new term for reset the Genesis block, so that everything that happened before that is outside of the scope of the protocol?
Sure. And if that's what we want to call it, then it seems like a nice thing to call it.
Sure. That way we don't name collide with what has previously been defined as regenesis.
To clarify, is state expiry dependent on the witness infrastructure?
It is not. It will be improved by it because it'll make the witnesses smaller, but it is not firmly dependent on it in any way.
Oh no, okay.
You could, well, you would, if we don't do Verkle trees, then state expiry would be dependent on Hexery Patricia tree branches, which we have code for, but like we would still need to do some more work on that code for, and obviously the witness sizes would be pretty large.
I think what I was just trying to say is that it could be done under the current Hexery Patricia tree, and it would be way less efficient, and like, you know, witnesses in the protocol would have problems being too large, but we just sort of like gloss over that for the development of this, probably with the assumption that we don't do that we look at making Verkle a dependency of this, or doing them at the same time, or who knows, but yeah.
Right. Like there's literally a factor of 10 difference in witness sizes between Hexery Patricia trees and Verkle trees.
Yes, got that. So with Verkle trees, there is no witness infrastructure that's needed. Users will like automatically get that. Am I getting that right?
What do you mean when you say witness infrastructure?
Witness infrastructure is, you know, do users have to go to some other service to be able to get their witnesses if they don't log in every epoch?
I think that's something that comes out of this, because at the protocol level, the protocol doesn't care about that. It's like not, the only thing that the protocol will probably specify is what is the format of that witness coming in through the transaction. But beyond that, like at the core protocol level, we draw like a hard boundary there and say, we don't care. And then later, once we've got this figured out how it works in the protocol, we can zoom out further and say, okay, cool, now we care, but separately, this is how we see some of that witness stuff happening. But this is like a layer 2 thing. where clients probably have an option for keeping around old epics. And there's probably services that spin up that keep around the old epics and maybe let you like buy witnesses from them or just give them to you for free. Or we do a big concerted effort and we build out work on the state network so that the state network can hold old epics and you can get them from a peer-to-peer network. But at the like core level, the protocol doesn't care.
Wait a second. I thought there was pretty definitively, you know, with all of these regenesis and per epic state expiry, the expectation is in protocol that somebody producing a block or a miner is required to produce a valid witness so that you can process a block without needing any additional storage other than the regenesis periods that you're holding.
I was assuming that Joseph was talking about witnesses for activating inactive state from old epics, not
Okay, so
block
that's the other
execution
side of it.
witnesses.
Yeah, so I guess we need to just make sure we keep the distinction that there's state that's necessary in protocol for people to validate blocks that are, you know, coming out of new block production. And then there's separately what's needed in order that you can understand how to create new accounts and to do transactions on existing accounts and contracts. And that's sort of the input side to the network. So in general state, and this maybe this is a reasonable segue if we've talked enough about the regenesis and the epoch. I think that was a very helpful discussion. I hope it definitely was to me. I hope for everybody else. But we could do a segue into, you know, Piper, if you wanted to kind of walk people through the kind of canvas of statelessness that you were nice enough to kind of write your high level view of.
Sure. Let me, so there's a, let's see, can whoever's got the screen give it to me?
Yep, sure.
Or you can, oh, I guess you've got it up right there. Well, anyways, I'll just share the same thing. Here we go. All right. So I wrote up this roadmap. I talked to a couple people about it. This is definitely not something that I consulted everybody about. So please feel free to throw your thoughts into this. I try to kind of cover like core stuff that we have to do, stuff that we probably should do, stuff that we can do, and that we still probably should do. The goal here is enabling statelessness at the like ETH2 validator level. So the ability to verify the state root of a block with just the block and a witness, but without actually having all of the state. And to do that, we've got to—
Can I ask you if you could just narrow the window that you're sharing a little bit? It has a lot of white space on the left and right.
Yeah, sure. Let's see.
Or just zoom in your browser.
Yeah, here we go. Thank you. Doing bad computer stuff.
Okay, cool, thanks.
Is that better? Okay.
Yeah. Piper, you're muted right now.
Size of about 200K, which is great because that's down from like megabyte size or more, that multi-megabyte size. The other thing that we have to do is mitigate state growth. That's not actually, I don't think, absolutely required for the ETH2 infrastructure piece of this, but it is one of the core goals that we set out to do with statelessness, was as a tool for mitigating state growth. And state expiry actually gives us what is roughly the equivalent of state rent through an indirect mechanism. The state expiry piece here still has a lot of unsolved pieces, and like we said earlier, we are looking for people who would like to sit down and really work on this, because it needs to be actually built out so that we can understand all of the pieces to it and actually flesh it out. That is the critical path. Those two things are the things that are on the critical path, and they're both big and complicated. But those are the two things that we absolutely, I would say, have to do. Anybody questions so far about kind of that reasoning or thought behind doing those things? Okay.
One question I had, I remember last time when we were talking about the 32-byte address extension. I don't remember who. I thought in the last call somebody had taken on that they were going to take a first look at what the implication of that was going to be, to get a feeling for how difficult that was, how many problems that was going to cause. Does anybody remember who that was?
I'm not even actually remembering that as a thing, but my memory is garbage.
Robert, was it Tomasz Stanczyk?
That might have been him, yeah.
He volunteered to I think maybe do specs or implementation of this. Maybe I'm wrong. I don't know.
Okay, we'll follow up because he's not on the call today and just see if he.
Yeah, and the address scheme extension is something that I don't know if it actually can get teased out of expiry and be independent, but anyways, it's kind of like going to be its own monster, and that's going to bleed out into the like user land and application layer. So it's something that getting started on sooner than later is going to be worthwhile, because I'm guessing that we're going to have some version of like a long tail of like, okay, we know how this is going to work, but now there's all of this time where we've got to give hardware wallet manufacturers and whatever some time to upgrade. Although I do believe that Vitalik has zeroed in on a nice mechanism for some level of backwards compatibility. I don't think we have to get too deep into that now, but I'm really just trying to highlight that there's stuff to be figured out down in there.
Mm-hmm.
I have this section here that I call the less critical path, which contains the kind of stateless client infrastructure stuff that I've been working on, and the what we should maybe rename as history expiry for dropping history. The history expiry piece here is essentially just a really nice, it makes sync better. It's like a nice reset mechanism, and it lets client drop all of the historical fork rules, which is I do not envy anybody who steps in and wants to implement all of the historical fork rules today. It's a lot of probably just reading other client code, just because it's kind of hard to dig up exactly what was happening at historical forks. Being able to drop all those would be really nice. And in terms of the stateless client infrastructure piece, this is what I've identified as what is needed for actual stateless clients to still be useful to end users, and as opposed to just being useful at this kind of like ETH2 protocol support layer. And that's something that I'm kind of chasing down on my own, or not chasing down on my own, but kind of leading separately and trying to get teams working on it. Questions about these two things? They are not critical to the ETH2 infrastructure piece, but I think that they are still relatively critical to still delivering some really high value benefits to our protocol.
So a quick one to follow up on my prior question, right? So now sounds like stateless validators are in the critical path, and I think everyone agrees with that. And so now with stateless clients, it's not so much in the critical path, because people who use services like Infura or run a full node, if we call it that, a non-stateless client, they'll just operate as normal. They don't have to go somewhere else to get their witness. Is that correct?
I've left the kind of like where do witnesses come from off of this, because I think it's going to be something that's emergent, that it's going to happen because of need, not because of planning. I mean, not that we don't need to plan for it, but that that the needs of the ETH2 clients that need to need the witnesses, that's going to sort of inform where they get generated, how they get generated, how they get them. And I don't think that from where we're at, we can actually say, this is exactly how they get generated. In terms of baking them into the protocol, I still think that access lists still seem like the actual thing that we end up baking into the protocol, which should still allow us to, I think, I don't know, I need to learn a little bit more about how Verkle witnesses are going to work, but, and whether or not we're still gonna be able to have a witness under the Verkle tree structure and verify that it is the correct witness with just an access list.
There continues to be one canonical valid witness for a given access list with a given state. So
Excellent.
We're good there.
Cool. So in terms of the protocol, we generally think that we know what we're going to do, access lists. And then in terms of witness generation and availability, I see that as something that's going to happen organically because of need. So. Did that answer your question, Joseph?
Yeah, it does. So as you explained it earlier, it's kind of like relying on layer 2 or the market to do that, which, I think we might want to think a bit more, because again, it might not.
No, I'm not proposing that we don't do it or that we shuffle it off the board. I'm saying that from where we're at, I think it's hard for us to we could plan out a gossip network and compulsory witness generation for minors and things like that. But I'm not sure that from where we're at, we can make a realistic plan. And I think that we've got a lot of time between now and Verkle. Basically, until Verkle is really even looking like a slated real thing, we don't necessarily have to have a solid plan for where witnesses come from. We should still have an idea for what they look like, how they get transmitted, whatever, but then the generation and transmission of them feels like a problem that we can solve when we know more. I'm not saying somebody can't work on it or shouldn't, but that it's just not, there's more important things to focus on for now. And then the last piece here is just sort of these things that got swept off. Binary tree and code merkleization were our previous plans for reducing witness sizes. They are completely replaced by Verkle trees, so we don't actually care about them anymore. We do care about code merkleization, but we're not doing it the way that we talked about before. We're just going to sort of bake the previous plans for code merkleization into the unified tree structure. Anybody have questions on that?
I guess one question is what's the time frame that so if we're looking for the merge, I think the last time we were talking about it, there was sort of the desire for the merge to be Shanghai, right? Which would mean it would be right around the end of the year. Is that correct?
That's certainly the goal.
Okay.
Well, conditional on reanism going well, obviously.
Conditional on, I'm sorry, on what?
On reanism, the merge hackathon that's starting up really soon, going well.
Okay. So
somebody can correct me if I'm wrong here, but it looks like the kind of natural ordering of this is Verkle tree, and then either at the same time or in either order, state expiry and history expiry.
So option 3, as we talked about in the previous call, basically does kind of do both of them at the same time, right? It says we initialize state expiry, and then every epoch except for epoch 0 is just going to be a Verkle epoch. And then after that, after we actually move into that epoch, then in the next hard fork, we can just manually figure out the Verkle root of epoch 0, because that's not changing anymore, and just swap it in.
I really like that plan. of doing them all at once. It's going to be a lot of stuff at once, but I think that there's potential for it actually being simpler to do all at once and just going ahead and getting it done.
This is my impression too. Like it's like 1.2 times the effort for twice the reward or something close to that.
And if we want to be, you know, since we're doing these other things and making some big changes, I think that there's like 2 other things that are on the EVM graveyard list, and carrying forward that momentum and doing all of that cleanup at the same time is really appealing to me. So it's something to look at. I'm not saying that we should do that, but something to look at.
But I guess my only
graveyarding at the same time does seem like a good idea.
So I totally get and appreciate that it's a lot more valuable to sort of do both of those. The one question I have is that, like, on the state expiry side, I mean, that implies we really do need to have a team or 2 working on that pretty soon. Or else that's not going to be possible. Because, I mean, the default is unless we actually get state expiry the work done, then, assuming that Guillaume is, and others are able to get the Verkle transition, that would be ready. But like we're pointing out, I mean, if we don't have the state expiry, then the only option with Verkle tree is to replace the current tree in place, which is not very desirable. Well, it's not as easy as if we have state expiry. I don't know. It sort of looks to me, Piper, thanks for laying this all out on this Canvas roadmap, is that, I think maybe there should be a higher priority in trying to, if we're not having somebody volunteer, maybe try to have discussions with the client teams and see if we can.
Yeah, I don't have this in any way. Like, I haven't even talked to EF, but I would be surprised if we could not secure funding for an established team to dedicate resources to this. So any of the client teams out there, if you guys want to take this up, I will work hard to get you the support to make that happen. So reach out, let me know. We need people to work on this. So, and if you've got an idea of a team out there that might want to work on this who's not here, let me know. I'll be happy to get an introduction.
Realistically, in order for the merge to happen with both Verkle trees and state expiry, it's really important that there's a team that's kind of, being the initial tank, breaking through the walls and getting the first implementation done. But I mean, this is one where every client that wants to participate post-merge is going to need to have both Verkle trees and expiry if they're part of the in protocol, because this is a protocol level change. So, I mean, I'm just kind of recognizing, this is a comment I'd just say, I don't think Alexi would mind if I'm saying this, but, as an implementer of a client, right? I mean, I think, it's a very fair comment of like, there's a lot of engineering work that would have to happen for these 2 things to happen. And we're looking at 9 months now. And, I feel like there's a certain amount of, I just want to raise it, like, it just looks like there needs to be, us lighting a fire under this effort, because otherwise, this is a really great idea, and it will beautifully take care of a lot of stuff and set us up for the future. But that future might end up being a year and a half away, or even 2 years away, unless we really prioritize encouraging, I won't put it, I mean, and obviously we can't do this in this community. We can't designate people to be volunteers. They really do have to be volunteers, but, we can encourage it. I don't know, Piper, if,
Another way to look at that is that if you're a client team, you're going to have to do this work anyways. And You could either do it on your own budget, or we could fund you to do it and figure it out for us as well. So I know everybody's always got a full plate, so it's not an easy thing. There's absolutely no like guilt or shaming or whatever happening here. It's just, this is stuff that needs to get done, and it would be great to get it prioritized.
Okay, we've hit 7:30, or sorry, we've hit the 1 hour mark. Apologize, this was an earlier call for me, so I'm a little bit focused on the time. So thank you everybody for being on this long. We're going to probably do, again, 1 or 2 topic meetings before the next general group discussion. We'll send them out on the regular email list so everybody will see the topic discussions that are happening. You know, I think there's probably the focus on the topic discussions from now till next time will be on those critical path items. I think a couple of us are probably going to put our heads together a little bit and try to think more about, on the, especially the state expiry side, what's a possible roadmap of encouraging client teams in order to get that to happen. Because, you know, what's that saying? The path to bad things are, you know, paved with good intentions. We definitely intend to want to do the right thing, but, you know, we need to actually get some action to move forward on it, or else it's not going to really happen in a timely fashion, or in the time that we are hoping when we say we'd like a merge to happen in Shanghai. You know, so I think that'll be a little bit of the focus in my mind. But other than that, thank you all. If anybody has any last comments or things they want to jump on, otherwise we'll see you next time.
And sorry, accidentally unmuted the wrong device. So after this, I'll probably drop some stuff into the ETH1X channel on any ideas that I currently have on how to get people moving towards this. And if anybody else has any ideas on kind of just how we can start, you know, getting stuff going on state expiry, I'd love to hear what you have to say.
Okay, cool.
Thanks, everyone.
All right, thanks everybody. Have a great rest of your day or evening, wherever you are.
Thanks, everybody.
Thanks, bye.
Bye.
Hey, Tim, are you still there?